Let's talk about reference angles. Let theta be an angle in standard position. Its reference angle is the acute angle, denoted theta prime, that's theta with an apostrophe, formed by the terminal side of theta and the x-axis. What does that mean? Well, here if I have some angle theta, theta prime, the reference angle, would be this angle right here. Notice it's an acute angle. It has to be between 0 and pi over 2 radians, and it is formed by the terminal side of my angle and the x-axis. Now, similarly, if I had an angle that was in the third quadrant, my reference angle would be this green angle here. Again, an acute angle between 0 and pi over 2 radians formed between the terminal side of my angle theta and the x-axis. Or if I have an angle in the fourth quadrant, the reference angle would be this angle here, the angle formed between the terminal side and the x-axis, the acute angle formed between the terminal side and the x-axis. One thing to make note of, however, all right, is that reference angles are always acute and always formed by the terminal side and the x-axis. So no matter where you are, always measure your reference angle to the nearest x-axis. Let's see if we can't find some reference angles. Find the reference angle, theta prime, in degrees, given that theta is equal to 300 degrees. Always helpful, again, to draw out a picture. 300 degrees. Where is 300 degrees? Well, that brings us into quadrant 4. Our reference angle is the angle formed between the acute angle formed between our terminal side and the x-axis. That would be that region right in here. So how would we find theta prime? We have to do a little bit of critical thinking. We know that if we take 300 degrees and we add on this angle here, theta prime, well, that gives us one complete revolution. Therefore, 300 degrees plus theta prime is equal to 360, and now we just have to do the algebra out to solve for theta prime. Subtracting 300 degrees from both sides of our equation gives us theta prime is equal to 60 degrees. There is our reference angle. Let's try another one. Find the reference angle given that theta is equal to 2.3. Well, we notice here there is no degree symbol present. That means we are talking about radians. So let's draw out a picture. What quadrant does 2.3 radians end up in? Well, we know that pi radians over here would be approximately 3.14 radians, and pi over 2, well, 3.14 divided by 2, that's approximately 1.57. It's got to be between those two values, so somewhere in quadrant 2. All right, we'll call that 2.3 radians, right about there. That means that our reference angle would be the angle between our terminal side and the x-axis, the nearest x-axis. Again, to find theta prime, we have to do a little bit of critical thinking. Hopefully we recognize that taking this angle, 2.3 radians, and adding theta prime, we have to end up with pi radians total. 2.3 plus theta prime is equal to pi. And now all we have to do is complete the algebra to solve for theta prime. That means subtracting 2.3 from both sides of the equation. Theta prime is equal to pi minus 2.3. And if you plug that into your calculator for a decimal approximation, we're talking about approximately 0.8416 radians. And one more example here of finding a reference angle. Find the reference angle theta prime given that theta is equal to negative 3 pi over 5. Again, always super helpful with these trig problems to draw out a picture. We need to rotate through an angle of 3.5 radians in the clockwise direction. Well, notice that 3/5 of pi, that is slightly greater than 1/2 of pi, but less than 1 pi. That means we're going to end up in quadrant number 3. there we have the angle theta equals negative 3 pi over 5. Where's my reference angle? My reference angle is going to be right here. Again, the acute angle located between the terminal side and the x-axis. How are we going to find theta prime in this case? Again, let's do a little bit of critical thinking. One thing to make note of here is that reference angles are always positive. And because the reference angles are always positive, it is often easiest to work with the magnitude of theta if it is negative. Magnitude just means the absolute value of the quantity. We know that if I take this angle here, the magnitude of it, that'd be 3 pi over 5, and add the angle theta prime, we have to end up with pi. That is a half of a revolution. Now, yes, I know it's going in the clockwise direction, but again, we're just talking about magnitudes here because reference angles are always going to be positive. So 3 pi plus theta prime has to be equal to pi. What algebra do we have to do to solve for theta prime? We have to subtract 3 pi over 5 from both sides of the equation. And now, if I want to subtract fractions, I have to get a common denominator. This would become 5 pi over 5 minus 3 pi over 5, which gives us 2 pi over 5 for our reference angle. All right, there you have finding reference angles. In the next video, we'll talk about why reference angles can be helpful and how to use them.